So to continue in our chapter, today we're going to talk about quadratic functions and we're going to concentrate on graphing quadratic functions just like we talked about yesterday, y equals ax squared plus bx plus c. So if you look at the different functions that we have, 2x squared plus 2x, 2x squared plus 4x, and 2x squared plus 6x, hopefully you have noticed that the changes that we have in our graph are all affected by the second term that we have, the linear term, and what we will refer to as that b. The coefficient of our linear term is represented by the letter b in our standard form. So this is one way that we're going to find the vertex. It's going to be easier than what we've done before. When you have y equals ax squared plus bx plus c, remember this is our standard form, okay? Then x equals negative b over 2a is the axis of symmetry and the x coordinate of our vertex. So it's a really important value to be able to calculate from the standard form. So looking at y equals x squared plus 3x plus 4, a is 1 and b is 3. So negative b over 2a is going to be negative 3 over 2 times 1, which of course is negative 3 halves. And y equals 2x squared minus 2x minus 6. A is 2, b is negative 2. So if I want negative b, then I'm going to put in negative 2 and 2 over 2a, and a is 2. So I have a negative times a negative, which is a positive. And hopefully you can see that a 2 on the top and the 2 on the bottom cancel, leaving me with positive 1 half. And then we have another one. A is negative 2. B is 4. So negative b over 2a. So I'm plugging in exactly what I see. And when I simplify that, negative over negative, 4 over 4, then we'll find out that it's equal to 1. So we're going to use that a lot to simplify our graphing process. So again, given a function in standard form, a quadratic function, we want to use negative b over 2a to calculate the x-coordinate of our vertex and our axis of symmetry. So the first thing that we're doing here is finding our vertex. A, hopefully you can see from here, A is negative 1, B is 4, and C is negative 2. Actually, we don't need that to calculate it, but it's still good to know it. So I have negative B over 2A. And that simplifies. Our negatives become positive. 4 over 2 is 2. So that's my axis of symmetry, x equals 2. I'm actually going to go ahead and plot that. X equals 2. So when you get that, go draw that dotted line. All right, so from there, you're going to go plug in plug in 2 in where you see x. So I'm going to say y equals negative, this would be x squared, plus 4 times x minus 2. And I'm plugging in this 2 where I had an x. So I plug in my 2. And when you simplify that, you find out that y will be equal to 2. Just put that in your calculator in one fell swoop, and you will find out that y equals 2. So x equals 2, y equals 2. That is my vertex, 2, 2. So I'm going to go over here. I'm going to go over to 2. It's always on the axis of symmetry, and go up to 2. That's my vertex. Now, hopefully y'all can see, but actually we'll go ahead and take care of it with our table of values. So with our key points, the next thing we're going to do is use our key points. Now remember the key points that we had before. We had 1, 2, 3, 1, 4, and 9. And then if we had an a value, then we changed each of our y's. So what is a equal to in this problem? A was equal to -1. So my x's stay the same, and I'm going to multiply each of these by -1. -1, -4, -9. So from my vertex, I'm going to go over and down and then use my axis of symmetry. This is what we call using our key points and A. Cut off on me. Key points and A. So from my vertex, if I go over 1, I go down 1. If I go over 2, I'm going to go down 1, 2, 3, 4. And if I go over 3, I'm going to go down 9, and that's off my graph, so I'm not going to worry about that point. So I go to each point, I count over to my axis of symmetry, over to the next point. 1, and then 1 again. So here's my parabola, and we're going to do our best to connect the points. And that is the graph of the function y equals -x squared plus 4x minus 2. All right, the next type of problem that we have is a word problem, your favorite kind, but it's following that vertical motion model. We had a motion model last time, and the nice thing about that is when you are using these models, they actually give you an equation, which is half the battle. So it makes it a little bit easier as you're working the problem. During halftime of a basketball game, a slingshot launches t-shirts at the crowd. So a t-shirt is launched with an initial upward velocity of 72 feet per second. The t-shirt is caught 35 feet above the court. How long will it take the t-shirt to reach its maximum height? And then what is its maximum height and what is the range of the function that models the height of the t-shirt over time? So, first off, we've talked about this parabola. You should recognize because of the negative sign means it goes down. So that falls in line with them asking us what our maximum height is. So the maximum when our parabola opens down is always at the vertex. So basically, if they're asking you for a maximum, you need to go find the vertex. So how did we just do that? We did -b over 2a. So looking at our numbers, we have a is -16, b is 72, c is 5. So if we go plug that in, we're going to have negative b is 72, 2 times a is -16. So if you put that in your calculator, you'll get out 2.25. All right, that's the x coordinate of our vertex. Okay, so if I'm trying to write the vertex, that's 2.25. And now I need to know what is the y coordinate. And remember, what did we do to find that? Is we have to take this and plug it in for x. You know, I said x. I should use the letter t because, of course, it represents time in this problem, not x. So we're going to go plug it in for t into our function. So my function is h equals -16 t squared plus 72t. Oops, my students aren't here to correct me. Plus 72t plus 5. So now what am I going to plug in for t? 2.25. 2.25, 2.25. So we're going to put that in the calculator just like we see it. And you're going to find out that h equals 86. So that is the y-coordinate of my vertex. Or in this case, they have t and h. So my points are t and h. Now, how long will it take the t-shirt to reach its maximum? How long means they're asking me for time. Okay? And remember, this was the t, so that's my time. So to answer that question, it is 2.25 seconds. That answers the first question. What is the maximum height? This is my maximum. So I get to answer 86 feet. Now the last thing they said, what is the range of the function? All right, we know this is the maximum height. I'm going to go write the range up here. So I know that it's less than 86, but I need to go back to read to the problem. It tells you that the t-shirt was caught 35 feet above the court. Okay, so think about that. It also tells us that the t-shirt is caught 35 feet above the court, but what's really most important is where did it start? And that would be at a time 0. How high was it at time 0? So if t is 0, this term falls out, this term falls out. So that actually gives us what we call the initial height. And so that also happens to be the minimum height. So the range of my t-shirt over time is between 5 and 86 feet. Now, if you're good to go, you may stop the video. The assignment involves doing a lot of graphs, so I'm actually going to graph 3 more. And once you get it, you can stop it and move on. There won't be anything new, but I'm just going to go through the process so that you can understand what's going on. So first off, find the equation of the axis of symmetry, the coordinates of the vertex, and graph each function. So for number 10, I'm going to find the equation of the axis of symmetry. So that's what we've done, negative b over 2a. Again, what is a? You can tell me that a is 1, b is negative 8, and c is negative 7. So negative b over 2a is going to be negative 8 for b over 2 times 1. Put that in your calculator in one fell swoop. Two negatives is a positive. 8 over 2 is 4. So that means my axis of symmetry is x equals 4. Okay? Axis of symmetry. Now I'm looking for the coordinates of the vertex. So I have to go take the 4 back in, plug it back in as we've said. Y equals, and I like to write that original equation, y equals x squared minus 8x minus 7. And what am I going to put in for x? I'm going to put what I just found. So that's my 4. And that simplifies to y equals 16 minus 32 is negative 16 minus 7 is negative 23. So let's go put our axes on there. And before we jump into that, we read the directions again and find out that we do not have to graph it. All we have to do is find the axis of symmetry, which we did right here, and the coordinates of our vertex. And my vertex, there's the x coordinate of my vertex, and there's the y coordinate. So it is 4, negative 23. So that's all we have to do. Again, number 8, you want to find out what A is negative 3, B is 12, C is 1. So negative B over 2A is negative B is 12, 2, and A is negative 3. And remember, we emphasize always put parentheses around any value that you plug in that's negative. My two negatives are going to give me a positive. 2 times 3 is 6. 12 divided by 6 is 2. So I have my axis of symmetry is x equals 2. That's my axis of symmetry. And I'm going to take that x value and plug it in. Y equals negative 3 times whatever I had for x plus 12 times my x plus 1. And what am I going to plug in for x this time? 2. And when I simplify that, 2 squared is 4. 4 times negative 3 is negative 12 plus 24 is 12 plus 1 is 13. So we get y equals 13. And we are going to write our vertex of 2, comma 13. All right, one more like that. Oh, a little different. A is -4. But notice that's not B because there's no x with it. So that means B is 0 and C is 11. So when I go to negative B over 2A, then B is 0. So 0 over anything is 0. That gives me x equal to 0 is my axis of symmetry. And when I come down to the equation and I plug in -4 times x squared plus 11, what am I going to plug in for 0? I'm going to plug in 0 for x. Anything times 0 is 0, so that means that the y-coordinate of my vertex will be 11. So when I write my vertex, I have 0, 11. Okay, so there's some examples of finding your axis of symmetry and coordinates of your vertex. We're going to do that 2 more times and actually put that on a graph, and then we'll be done. So f of x equals x squared plus 4x minus 5. A is 1, B is 4, C is -5. So remember, we're finding that vertex using negative b over 2a. So negative b over 2a, b is 4, and a is 1. So that's giving me -2. And we like to write that's x equals -2. That is my axis of symmetry. Okay? And then I'm going to go plug that in. Y equals, and we write it with our parentheses, and then we're going to go plug in -2 for x. And when you plug that in, you're going to find out that y is equal to 4 minus 8 is -4 minus 5 is -9. So your vertex is -2, -9. So let's put our axes on our paper. And we're going to go to -2, -9. I think we might, that was the wrong one. -2, -9. Am I going up or down? Hopefully you know that A is positive, so we're going to be going up. But I'm starting at -9. 2, 4, 6. I got to come up here. Let's see what happens with this. So, if I go by 2's, let's label it by 2. So this is going to be, actually I'm not going to do it by 2's. 2, 4, 6, 8. So this is 2, -9. And as we did earlier, remember that's my axis of symmetry. So I'm putting that through there. -2, -9, my A is 1. So the next thing that we do is we look at our key points, and I'm trying to put them over to the side. My X and my Y, 1, 2, 3, 1, 4, and 9. My A is 1, so those don't change, and so from this point, I'm going to go over 1 and up 1. You got to mess that up there. Over 1, up 1. Over 2, up 1, 2, 3, 4. When you do these over and up, it's always from your vertex point. 1, 2, 3, up 9. Well, we already knew we were down 9, so we're going to go there. And now I'm going to count back to my symmetry. 1, 2, 3, 1, 2, 3. Using my axis of symmetry to finish my graph. 1, 2, 1, 2, and go over 1, and then over 1 again. And so we're going to connect our points. And then we'll be finished graphing our parabola. Okay, look at 22, and then we'll be finished with our examples. All right, we have A equals -2, B is 8, C is 9. So sometimes it's good to notice when A is negative, go ahead and write my parabola has to go down. Okay, we're going to go calculate negative B over 2A. So that's negative, B is 8, A is -2. So my two negatives means my answer will be positive. 8 over 4 is 2. So that's my axis of symmetry. X equals 2. And from there we got to plug it back in. So y equals -2 times x squared plus 8 times x plus 9. And what am I going to plug in for my x? I'm going to plug in what I just found. So that's 2. And when we simplify that, we find out that y is -8 plus 16 is 8 plus 9 is 17. So my vertex here is 2, 17. And I'm going down. So let's put in our axes. 217. So I got to go up high. Okay, it's crooked. And let's try. I'm going to have to number this one by 2's to fit on my graph. Hopefully that won't be a problem. Before I actually put those points, or we'll go ahead, let's see. 2, 4, 6, 8, 10. Let's go by 2, 4. So let's label this 2, 4, 6, 8, 10, 12, 14, 16, 18. So if I have the number 217, we can go ahead and do this one by ones to make it a little easier. So I'll go 1, 2, up to 17, puts me right here. And remember, that's where our axis of symmetry is. And that line has to be dotted because it's what we call an auxiliary line. It's not part of the graph, it's just helping us graph. So we have 217. Now we got to look at our key points. Okay, remember we started with, actually I'm going to change. We started with 1, 2, 3, 1, 4, and 9. But what was my A value? My A is -2. So that means that I'm going to multiply each of my y's by -2. My x's will stay the same. So 1 times -2, -2. 4 times -2, -8. 9 times -2, -18. So watch how we're going to graph that. Again, over. So this time we're going to go over and down from the vertex. So here's my vertex. If I go one by ones here, so let's label that so we don't forget. 1, 2, 3. Okay. So from this point, if I go over 1, I'm going down 2. If I go over 2, I'm going down 8. If I'm going over 3, I'm going down 18. And once I get to that third one, it's still on my graph, and I'm going to count over to my axis of symmetry. 1, 2, 3, 1, 2, 3. From this point, 1, 2, 1, 2. And from this point, 1 and 1. So we're going to do our best to connect and we'll be done. Okay, that one kind of missed. I'm going to come back on it. Come. Do your best to get that vertex again, not to make it too pointed. And use your eraser if you need to make it look like a parabola. So we have finished graphing quadratic functions for today.